The purpose of this video is to finish up what we were discussing today in class, and then you'll have a chance to practice tomorrow. So we're going to talk about both box plots and numerical summaries. This is the last slide that you saw when we left class today, just showing you differences between the mean and the median. These are measures of center and describe the typical value of a distribution. So take some time to read this over. You may want to pause the video while you do this. And so as we look at the mean, median, mode, we know that those are measures of center, and then we also have range so far that we've used as a measure of spread. Take a look at these three very different data sets and calculate the mean, median, mode, and range of each of these. And let me know what you notice at the end. You won't actually be able to tell me, but you could say it out loud, and I'll pretend like I hear you anyway. Pause the video while you work on this. So hopefully you saw the following, that the mean of each data set is 5. The median of each data set is 5. The mode of data sets A and B are both 5. However, for set C, because we have 9 and 1 occurring in equal frequencies, they both would be considered the mode. But for all three sets, the range is 8. And so when we talk about a typical value, it's fine to report that, but we can see that these three sets have very different values contained within them. And so what we come to find is that the center is not sufficient to report as a numerical summary. We also need to discuss the spread. And so that brings us to talking about standard deviation and IQR. We just saw the range. The range doesn't give us a whole lot of information aside from the highest and lowest values. And so we'll spend some time in this series talking about the IQR, and then over the weekend you'll watch another series that discusses standard deviation. This gives you information about percentiles and quartiles. Take some time to read over it. Pause the video while you do so. And then we have the 5-number summary, which consists of the minimum, Q1, or the lower quartile, and then you have the median, Q3, also known as the upper quartile, and then you have the maximum. And to show the 5-number summary, we use Boxplots. Once we find the quartiles, we can then find the IQR, or the interquartile range, which is found by subtracting upper quartile minus lower quartile. And this gives us the range of the middle 50%. Instead of going from highest to lowest, where those values could sometimes be extremes, we could focus on the middle 50% that tends to be more consistent. And the Outlier Rule says that if I take 1.5 and multiply it times that difference known as the IQR, subtract that product from Q1, any value less than that difference is considered an outlier. I could also take that 1.5 times IQR product, add it to the upper quartile, and any value in the data set greater than that will also be considered an outlier. Now, keep in mind that this does not depend on shape. So I could use this rule for a distribution that has any shape, whether it's symmetric, skewed, and later in chapter 2 we'll talk about normal. So let's find the 5-number summary for our pulse rates, and then we can draw a box plot to show those. If you take your list of pulse rates, you'll notice that we have 45 values. Notice the 46th person did not respond. And so the median would be the value that's directly in the middle, so that's the value that's in position number 23. So in this case, our median is 72. Then if we take those upper 22 values, we can find Q1, because Q1 will be the median of those upper 22 values. But notice that there is an even number of values, and so we have to look at the value that's halfway between position 11 and position 12. So for Q1, we're actually averaging 65 and 65, since those are the numbers that are in positions 11 and 12, and it turns out we get 65. If we go on the bottom half, so now we're looking at positions 24 through 45, we're going to run into the same thing. So we need to be looking for the halfway mark between positions 34 and 35. So we're averaging 84 and 85, and so Q3 gives us 84.5. And then we have our minimum value. We can see that it's the smallest pulse rate, which is 45, and our maximum value, which is the highest pulse rate of 120. And so now all I need to do is just to set up a horizontal scale and begin to draw in the features of the 5-number summary. We start with the minimum, which is 45, and what we're going to do is just put a vertical line. So halfway between 20 and 40 would be 60, so I'm going to place that vertical line. Sorry, halfway between 20 and 60 would be 40, so I'm going to place that vertical line about there. I'm just estimating here. And then the next thing I want is my vertical line for 65, which is Q1. So I'm going to place that about here. Then I need a vertical line for the median, which is at about 72. So I'll place that here. And again, I'm just estimating here. It might not be exactly correct. For Q3, we want to be at 84.5. I'll put that about here. Now I'm going to connect a box that goes from Q1 to Q3. And that's how we get the name the box plot. Next, I'm going to draw a vertical line for my maximum value, which is 120. And then I will connect the minimum to Q1 with a whisker. It's just a horizontal line. And Q3 to the maximum with another whisker. Again, with the horizontal line. And so this was called a box and whiskers plot, and we've just shortened that now to just mean a box plot. So what I have represented again here is the minimum, followed by Q1. The median's in the middle of the box, or somewhere inside the box, I should say. And Q3 is the last vertical line on the box. And then the last line is always the maximum. Now this is a box plot that has not been modified to show outliers, and we'll do one of those as well. In order to determine outliers, I need to follow the 1.5 IQR rule. Recall that IQR is found by taking Q3 and subtracting Q1. Let's get that fixed for you. Q3 minus Q1, which means I'm taking 84.5 and subtracting 65, so my IQR will be 19.5. I then take this number and multiply it by 1.5. So 1.5 times 19.5 will give me 29.25. Now to determine outliers, I need to take Q1 minus 29.25. That's going to give me my lower boundary, so that's 35.75. And then I need to take Q3 and add 29.25. That will give me the upper boundary, which is 113.75. So if X is less than 35.75, or X, which is a data value, is greater than 113.75, then I have outliers in my data set. So take some time and look at your list and see if you notice any outliers. Hopefully you see that 45 is the lowest value we have, so there's no way we'll have a number in our data set less than 35.75. And we do have one value that's higher than 113.75, which is 120. So we would consider 120 to be an outlier. Now that will change our box plot just slightly. We'll start off the same way. So our minimum is still at 45. Q1 will still be in the same place. That won't change for us at all. Q1 is still going to be at 65. The median's not going anywhere. It's still going to be at 72. Q3 won't change at all. That will still be 84.5. I'll still connect the box. From Q1 to Q3, I can still connect the min to Q1 with a whisker. And now things are going to get different. Because 120 is an outlier, I'm going to show it as just a dot or a plus. You can use whatever symbol you want to indicate the outlier. But I still have to finish off this box plot. So what I'll do is pick up the very last number right before the outlier. So if you look at the bottom of your pulse rate list, you see 120 was the maximum, and the next highest value was 110. And so I'll place that here, and then I connect Q3 to 110. Now, one common mistake is that students now want 110 to be the maximum, but I need you to be really logical here. 120 is a data value. It is not bigger than 110, so 110 cannot be a maximum. In the modified box plot, we show outliers on either side. If there had been outliers down here on this lower end, we would have shown them down here as well. So if you take a look here at the labels, we have the minimum, Q1, the median, Q3. We have 120, which is not only the maximum, but also an outlier. So keep that in mind as you're creating modified box plots. These are calculator screenshots from the TI-8384 to show you how to do this on the calculator. So first there's one variable stats. We saw that in class. That's just stats followed by calc. And then it's number 1. Make sure you type in the correct list. The second one shows you how you get to the modified box plot. And as a reminder, that's second, followed by stat plot, which is your y equals button. The third one just shows a window change so that you can see what's going on in this fourth one. And what I did was show both the histogram at the bottom, and the box plot at the top, and you can see that this little square out to the side shows on our outlier. Notice that we can tell the shape is skewed to the right. We had already looked at this according to the histogram, and so now we see it according to the box plot as well. Notice the median is a lot closer to Q1 than it is to Q3, indicating a cluster of values on the left-hand side, and as a result, we're going to see a peak on the left-hand side, which supports our decision for being skewed to the right. I'm going to stop the video here. There is another part where I want to talk about shape and also describing the distribution, but I'll do that in a second video. So there will be a part 2 to this for the descriptions.